Okay, what we have here is two web applications. They're sister web applications. They look very similar, as you can see. In the top half of the screen I have got Suncalc. In the bottom half of the screen I have got Mooncalc. As you can see, the web addresses there, suncalc.org and mooncalc.org respectively. I'm mainly going to be doing this demonstration in Suncalc simply because the moon in all locations all around the world, every day it rises and sets at different times. So it can be a little bit confusing to know what would be right. You know, if I move to Moscow and it says the moon sets at such a time, how would I, unless I'm a very keen astronomer keeping updated on this stuff, I might not really be able to know. We can safely assume that both of these applications work in exactly the same way because you've got, well, it's simple, isn't it? Suncalc, Mooncalc. They both have exactly the same interface going on. You know, the information that it gives is very similar, obviously a little bit different for the moon, but you know, basically you've got the same interface. So we can safely assume, I don't think it would be untoward to assume, that both of these applications work in exactly the same way. Okay, so what I'm going to do by way of a little test to verify if what I'm stating is correct, I'm going to move my Suncalc first. As you can see at present, I'm located in Stockport in the United Kingdom. My time zone is UTC+0 because I am actually in Stockport in the United Kingdom at the present. And I'm going to change my location because what I believe Mooncalc does is it shows you the same moment in time. If my time's fixed there at 8:45 and I want to know what was going on in Sydney in terms of, you know, where the sun was in the sky, where the moon was in the sky, I'd simply change my location to Sydney and boom. Okay, I've now got Sydney showing the sun. Looks like it's just about to set. Yeah, in fact, according to the altitude here, it has just set in Sydney at 8:45 UK time. Down here it's showing me that it's 19:45 in the time zone UTC+11, which would be Sydney. Yeah, so this time bar at the top is simply showing me my time where I am, not Sydney's time. Okay, so my time, this is what's happening in Sydney. Now, to verify this, I'm just going to move this bar just a smidgen. See that? See the sun effectively becoming a grey dot? That's showing you that the sun is setting at 8:45 around that time in the UK. And as you can see down here, if you watch this, you've got 1945, 1938, you know, as you go forwards, boom, there's the moon set about 1947 according to Mooncalc. Okay, now to verify, sorry, that's Suncalc, but to verify, I'm going to check with timeanddate.com that I am indeed using this software correctly. And if I pull up sunrise and sunset times in Sydney, as you can see, Sydney, New South Wales, Australia. Today's, obviously we're in February 2016, and the day is the 19th. So on the 19th, the sunset is shown at 19:44 Sydney time. This is 256 degrees, so it's just setting in the southwest. If we go back to Suncalc, as we can see, the local time here is showing 19:46, and the sun is just setting around that time. So that means that at 8:45-ish UK time, the sun sets in Sydney, which adds up. That's what we would expect. So if we then go to Mooncalc and simply move that to Sydney, it wouldn't be a stretch to assume that, I'll just shift the time back a few minutes here for Suncalc because I was messing with it before. Okay, so we've got both clocks now at 8:45. So it's safe to assume that the sun location and the moon location at them times are synced because both applications work in the same way. And we've checked with time and date what time the sun set in Australia, and that was 7:45 or 1945 if you like. So it all ties in, it makes sense. Okay, that's the first part of the demonstration done with. What we're going to do next is have a quick look at Flat Earth Guru Antonio Subirats, a present rising star in the Flat Earth world, because he's based rather a lot of his body of work, discovering that the Earth isn't actually a globe, it's actually flat. And he's based a lot of his work on using these applications, particularly Mooncalc. Now, as I explained before, I've based my demonstration on Suncalc more because we all know roughly what time the sun, you'd expect it to set in Sydney at 7:45 local time. It's not a stretch to think that might happen. So we're going to have a quick look at what Antonio says is the correct way to use. He's talking about Mooncalc, but as we've said, they're the same application. One's for the sun, one's for the moon. I don't think it would be a stretch to assume that we use them both in exactly the same way to determine the position of the two celestial objects. So let's have a look at what Antonio's got to say.
This is what happens when you use Mooncalc incorrectly by only moving the pin, by not adjusting the time to the pin's location. You must adjust the time. So let's go back to Stockport. And let's adjust the time. And you'll see it's quite simple. How you adjust the time is Mooncalc has basically got everything there that you need. So we see here at the bottom it says, remember we're looking from Stockport, the computer thinks it's in Stockport. It says 11 AM in Stockport is 04 UTC-6, which is Calgary. The reading now reads 21 UTC, which is Calgary's relative location to Stockport. Now for Stockport it says 20. Now here we have to compensate for an hour, which is a 2-hour discrepancy between Stockport's UTC and Sydney's UTC. The moon from Calgary now heads over this frozen land, the moon from Stockport over that frozen land, and the moon from Australia over that frozen land too, at 11 England time.
Okay, now that was enlightening. What I'm going to do now is I'm going to use the Subirats method to, as he says once you change the location, you must then adjust this time bar at the top of the screen to accurately show the position of the celestial object in question. In his video, of course, it was the moon, but as I've said earlier, I'm going to use the sun calc because we're more familiar with where the sun should and shouldn't be at a certain time. That's the only reason I'm using it by way of demonstration. It's not because I couldn't prove the same thing in Mooncalc, it's just it's a bit more obvious in Suncalc. We know roughly, for example, the sun doesn't rise late in the evening and stay light all night. Not for most of us anyway. And I'm sure any of our Australian viewers that might see this video could confirm that at this day in the year, the sun didn't rise at, in the night. So, moving swiftly on, let's use the Subirats method to establish the location of the two celestial objects. So I'm just making sure my time's set, and I'm using a touchpad and fat fingers, so that's why there's a bit of messing around with that. But we're in Stockport now, 8:45 in the morning. Okay, we move to Sydney, and I'll do the same in Mooncalc. Sydney. Now, what the Subirats method dictates is that this is not enough. This isn't the position of the celestial objects at this time. What we have to do is we look at the local time down here and we go, okay, it's 1945. in Sydney. So what we now have to do, apparently, is take this time bar and move it to 1945. 1945. And I'll do the same on Mooncalc. And we're at 1945. Okay. Can anybody see a problem here yet? Because I sure can. Okay. Let's have a look. What this suggests now is that if, as Antonio claims, this is now showing the position of the moon, the position of the sun. Yep, because I've moved the time bar forward to represent 1945 Australia time. So what this would mean, if his assertions were correct, was that at let me see, it would suggest that the sun rose in Australia at about 1934, 35. So what we'd have is the sun rising at night. Now, I don't know about you, but that doesn't really make sense to me. So, yeah. But that's what we have. According to Flat Earth Guru and Rising Star Antonio Subirats, that's correct. Beats me why you would think that. Like I say, I'm not going to go into the moon at the moment because it'd just involve a lot more effort. Using the Mooncalc, we can do it quickly and we can say, does the sun rise at 1945 at night in Australia? I would say that's absolute nonsense. Okay, thank you very much. Goodbye.